Hello, my name is Yael Oosthuizen, and this is my video presentation of my final for Csci 161. So normally, I'll go through the code first and do a video or a demonstration of my code at the end, but I think this is a pretty big game and it'll make more sense when I'm explaining the code if I do a video demonstration first. So we're going to start with a demo of everything in the game, and then we'll do a run through of the code. So starting off here, we have the main menu. Up here, you can see that there's a high score, and I've done some ASCII art to have your options. So we can start by pressing A. And now we're given a welcome message. Here I'm given 3 options, 3 planes I can fly, or ships. And they each have different characteristics and power-ups. So we'll go through each of them. Why don't I start with the space station? This is the biggest ship. It has the most shooting, so it shoots 4 bullets at the same time, but it's quite slow. Its power-up is double speed. And yeah. So as you can see, it's quite slow moving side to side. The goal of the game is to destroy the asteroids before they hit the Earth. It would be comparable to a shotgun. Wide range, but slow. And here we have the difficulty increasing by 1. And an increase of difficulty actually makes the asteroids fall more commonly. So the difficulty goes up to 20. And now we have a power-up. So you can see the rocket ship moving side to side quite a lot faster. And below power-up it reads, or there's a bar, and that's going to go down as I use up my power-up. And once that hits 0, my power-up goes away. And I have to destroy 10 more asteroids to get that power-up back. It's a pretty big boost, so it goes to double speed, which is pretty exciting. And we can see our difficulties up to 3, and our score is 19. So if you pass the high score, then your score will be set, and you'll be able to see your score in the main menu as your high score. Otherwise, your high score doesn't change. So if you look now, we don't have the power up anymore. If you let an asteroid hit the Earth, you're going to see this message, we let an asteroid hit, and we go back to the main menu. And the beauty is we have a main menu that circulates, so you can play this game over and over and over. Now we're going to fly the mini shooter. Again, we have our text. And just keep in mind that you can always quit. So press escape to leave, and it'll also exit the game. You can see this one is a lot faster. It's got a wider range. It's quite a bit less accurate, so you normally have to shoot a few times. This would be comparable to an SMG. So as you can see, that first bullet missed. So the power-up for the mini shooter is double score, which means for every asteroid I shoot, my score will increase by 2. So as we watch, our score is at 11. I destroy this, it goes up to 13, 15, 17. So that's the mini shooter. This time I'm going to press escape to exit. And finally, let's look at the fighter pilot. So the fighter pilot is kind of mid-range. The speed is just a bit less than halfway. So it's closer to the space station, but it's still faster. It has a more narrow shot, so it still only shoots one bullet at a time. But since we hit each position, all your shots are going to hit if you're lined up correctly. So this would be comparable to an AR. And of course, with any of the ships, you can hold to get a rapid fire. The power up for this ship is extra shots. So you go from shooting one at a time to two at a time, which is a pretty valuable power up in late game. So now, when we shoot, we're shooting 2 bullets at a time, which makes for a pretty awesome rapid fire. You can shoot down anything in your way. And you can see as we're difficulty's going up, there's becoming quite a lot more asteroids. Like, those are all quite close. So I'm going to play through a little while longer, as long as I can. And we'll see the asteroids increase. Yeah, wow, so that is the difficulty at its max, and yeah, that was just too much for me. This is the game. I can quit the game. I'm really excited about it. I really enjoy playing it, and I can definitely get distracted. So the extent of my story is really in the setup. So we have the intro, and you get to choose which plane you want to take. So that's a prompt user, and then you get a little bit of a description of the plane, not much. When you die, there's a little blurb that says, I mean, it's quite dark, but essentially you've exploded the Earth and the game is over. We've also got the good luck, try not to break anything. And finally we have this dialogue which pretty much says you've been tasked with keeping the Earth safe. There are giant asteroids flying towards the Earth. Can you shoot them down? And that's really the extent of the story. So for the narrator, I've written the split function. And that's really all. It's more of an action-based game, so there's not much story. So, for memory management, I've filled in a struct called arguments. And this has quite a few variables, and it's a shared pointer throughout the game. So multiple classes have access to it, and if you change the variable, that pointer is shared, which is really helpful. So I can, in any class, change the game to done. So once you die, we're able to wrap up as quickly as possible. So that's what done and dead do. There's also pause animation and a sleep, which lets you sleep other threads while, so if I'm in one thread, I can sleep another thread, and that's used when I'm running through shapes. I don't want to delete a shape that I'm checking the position of, because that would cause a segmentation fault. So I'm actually going to sleep the thread that's deleting the thread, or deleting the shapes, until I've run through all the shapes to, find their location or whatever I'm doing that for. And then I can reawaken that thread, and it can go back to clearing shapes. We have the score. That's shared through everything because I want to increase the score in every time an asteroid is deleted. And you'll see that that function is a pretty important function, deleting the asteroids. Lots going on there. But then in the main menu, I want to display the score, and I also want to set the score if you set a high score. And so that needs to be a shared pointer. And finally, we have the difficulty, which again starts at 0, and I want to access that through multiple functions. So that's a shared pointer. Finally, we've got the player and a few other things like key press. So just looking a little bit more at the memory management, here we have window.cpp. That's in the GUI. So I am deleting shapes if they're overlapping. That's what this series of nested if and else statements does. So I'm checking the position of each, the bullets and the asteroids, which each have a type. And so that's a pointer. So that's the shared pointer we looked at, and shapes. And there's actually a vector array of shapes. So I'm checking the type, and I'm checking the location. And if they're overlapping, we're going to erase those shapes from the, so that happens down here. Erase those shapes from the vector array. And those have to stay in sync because I'm adding bullets in a different function. So I think that this function is also the function that was the most difficult to program. And that's for a lot of reasons. So I'm considering this function to be the one that was the most difficult to program, even though I actually did all the programming in a different function and struggled there for a long time. And when I did figure it out, I was able to bring the clean code to this function. Essentially working with the hitboxes, we have the vector array, and deleting the vectors, or deleting the shapes from the vector array was quite difficult. And I struggled with that for a while. First, trying to work with a list, and eventually I did change it to be a vector, which was very helpful. And learning how to use the dot erase. And there's a lot more that goes on. So I also brought over the generation of the random asteroids. That was also being done elsewhere. And up at the top, this is using the shared pointer sleep. So this is to sleep this thread if I'm looking at the shape array in another thread, so that I'm not going in and deleting shapes like I talked about earlier. And below that, we've got another erase. So I need to erase the bullets once they hit the top of the screen, or else my array is just going to get really, really long, because I might be shooting well over 1,000 bullets in a game. And so to keep code running quickly, I'm deleting the bullets at the top of the screen. And so this is checking all the bullets and checking their position, and if they're at the top, I'm going to delete those bullets. I do some graphics here. So I want to fill the back panel, and I'm actually filling it black. I thought that was quite fitting for outer space. Then I'm updating the shapes. So I'm drawing all the shapes. So that's drawing all the bullets. and that's drawing all the asteroids. Then I draw each player. So each player has their different own drawing, and that's polymorphism there. So I'm passing in panel so that they can draw to the specific panel that I'm using in the window class. And I pass that to the draw function within the shared pointer of the player. And then I draw the Earth down here. I thought I could potentially draw a circle, but this was actually less code and faster. I then print the score. So in all, I think that this was the most difficult function to program. As for gameplay features, there's a lot. Things that I was really excited about to get working were the power-ups. So those are each specific to each plane. A lot of that happened in the window. So we can see here this power-up is displayed on the screen. That's the graphic of the bar going down, and that's its own function. So I print the bar. We also have a power-up for B, which happens depending on the score. So if score mod 20 is greater than 10, we're going to see a power-up for B. The score, if you have the power-up, is going to go up by 2, but that's just for B. So because the A has extra bullets, we do a call for A. And if the score mod 20 is greater than 10, we're going to add a second set of bullets that are farther apart. And finally, for the player class C, which is the big ship, if we're score mod 20 is greater than 10, we're going to set the speed to 1.4, whereas it's typically only 0.7. So that's the power-ups for each rocket ship. So another feature that I think is really cool is the high score, and that's actually writing to a text file. And so we fetch the high score here, and as you can see, if our high score is larger, we're gonna set the high score. So that's exciting. So the constructors for the pilots are very important because I'm setting the health, I then have the speed, and because I always want, when I create a player B class, to be speed to be 2, I'm actually just creating a player B and setting the superclass player speed to 2, and then I'm sending in the type. So going back to superclass player, we have some setter and getter functions. So we can look at set speed, which is important to the power up for the large space station. So I actually need to set the speed, which is protected by the class design, but I have a set function, and I can get that because it's protected, but I need to set it from the outside. And so going back again to player, we have protected because I want my subclass, all the pilots, to be able to access their own health and their speed. Because, for example, the speed, I need to have access that to be able to draw the pilot and update the pilot. And I want the subclasses to have access to that. Similarly, the type. So this is important information, but I have it protected. That way, it's not publicly available, but my subclasses have access to it. I was really excited to program the drawings for each of the players. So that happened within the player class. So if we look at the player.cpp, I'm setting each point, and that's because it's not a specific shape or a line. I've designed each of these planes to have very intricate design. I really like the graphic design. I also enjoyed drawing in the main menu, doing some ASCII art, and so it looks like this before it gets printed. I thought about having this font all the way through, but I really like the letters, the neat letters, because you can have an upper and lower case. They'll look really good. Some more curve to it. So I thought that was really fun, just doing the art. So going back to this draw function, this is an example of inherited superclass function. So the function is draw, and it's a virtual function. So that's passed down to each, but each player has a completely different drawing. So even though I need to draw for each, player, I just call the draw in the args array, and I call the superclass draw, and they each have their own drawing. So that's variance between each of the subclass implementation of the superclass code. I've actually got quite a few virtual functions here that we're using. So we have the draw and we have the get type, because they each have their own type, and I want to be able to access that on a super level. And in the superclass we have get speed and get health, so I've left that in. There's damage, and get location is a very important function. So I'm using that for all the shapes that I create, all the actors. So I need the location, but I don't want to copy paste that for each of the different pilots. So that's on the superclass level. And we have all the direction control. That's all superclass. So the reason that it's important to have a superclass and subclass for the actors or the pilots is we have 3 different plane designs, which are each subclasses of the player class. So it would be a lot of work to write code that's identical for each of the 3 of them, but having a lot of the code be in the superclass player, I can really only do the specific code in each of the pilot classes and leave the generic code like get location to the player class. things that stay the same. So get type, get speed, all those things are adjusted in the superclass.